iterable, iterator, and generator. So these three things, like we said, what is iterable? Iterable is any object that is capable of returning iterator. Iterator is any object that supports iterator protocol. What is iterator protocol? Iterator protocol is nothing but a returning a next value upon calling a next magic method. So it acts as a stateful object, and every time we call next, it returns a next value, produces a next value. Generator is a function, basically a function, which is a generator is a way to define an iterator using a function. Okay. So let's see how iterator works. So we have iter magic method also, magic method, as well as a built-in a function. Python 3, if I go to interpreter, and we have built-in function iter. So to this function, you can pass any iterable. So when you pass iterable, this function returns a iterator. So if I pass a sequence, which is let's define a sequence x equal to hello world, okay, and itr equal to iter of s. So check what is itr, which is a iterator. Can you see? Okay, so every time I call, how this iterator works, we have next. So this is called iterator because it supports iterator protocol. Okay. So what is iterator protocol? Upon calling next, it returns the next value. So it keeps the state of what is the current value. So ITR, check. Every time I call, it is returning one by one until the end. And at the end, we get the stop iteration exception. Okay. So let's do one thing, ITR x equal to, now call ITR off, and instead of giving a sequence, let's give some 8 random integer. What we'll get an exception. Check this one. Int objects is not iterable, which means that an object that integer 8 we passed of type int is not iterable, which means that it is not capable of returning iterator. Okay, so what are iterables? Any object that is capable of returning iterator is a iterable. What are iterables? All sequence types are iterables. Okay, so you can see here in the exception, not iterable. So what iter does, this iter function, built-in function, if that is the object we pass is iterable, it creates the iterator out of that iterable and returns that. Okay, check out this one. We have a list L equal to colors. Okay, green, orange, okay, blue, pink, peach, yellow. Okay, we have these different colors. Now if I actually call iter colors, okay, I just don't want to use that big name, no, so ITC I call simply iter colors. Okay, so iter, and if I call colors, see, since it is a sequence, all sequence types are iterables. Okay, so all capable of returning iterator. So now if I call ITC dot, I can call either next magic method, okay, or I can simply call next of ITC. You see, it is continuing from their green, orange, blue. And remember, so I can use this with for loop also. So remember what this for loop takes a sequence and iterable. Okay, so since I give iterable here, and if I print I, and it will print from yellow. So yeah, it is not printing anything here because we already used all of them. Okay, try out again ITC. Okay, next of ITC. Okay, so what for loop does now, I won't get from green, orange, okay, from blue I will get. Okay, because I used I called I next twice. What for loop does, for calls the next, okay, until it gets the stop iteration, and then once it gets the stop iteration exception, it stops. Okay, can you see here blue, pink, peach, yellow? Okay, using classes. Okay, so how do you implement iterator? Okay, so we can see, we have seen here iterables and iterators. How do you actually, by using classes, how do you implement class? Okay, my iter. Okay, so I can define what is this we have called a magic method. Okay, so sorry, define, so init is a constructor. Okay, so I just I'm putting nothing in there. So I have a iter. So when I call this thing, okay, when I pass, what happens? What happens when you actually uh, to iter function? What is if you call an iterable, what it does? It calls magic method. Check this thing out. Okay, I have a string. Okay, check this thing. We have that. Yeah, iter magic method is there. Do you see this one? That is called. Okay, that is the reason we call it as a magic method. They are called, behind the scenes. Okay, I am defining iter. Okay, so what the arguments it takes? It takes nothing. Okay, so when you call this one, instead of calling that, we have magic method itr. Okay, so it takes nothing, but it returns what is called iterator. So when you call this, and so I can take this I can define something called colors, which is a class attribute. Okay, define some red, blue, green. Okay, orange, pink. Okay, so what it is, it does, it returns itself. You can, and don't forget about self. Okay, yeah. So and now when you call, okay, next. Okay, so it should return current value. Let's keep this thing self dot current. Okay, index. I'm actually, what I'm doing myself, I'm creating some iterator object. Okay, so blueprint class, a blueprint for iterator. Okay, so I don't have to do go through all of this, and I don't have to go through all this effort by using generators. That one we will see in a moment. Okay, so current index is 0. Okay, what I can do, self, okay, and try index out of range. If I get the index and out of range, I would raise the stop iteration exception. Okay, return self dot colors of okay, self dot current index. Okay, and self dot current index equal to, I wanted to increase this by 1, except index error and rise stop iteration. Okay. So what happens if I want to use this one? Mm, let's exit this one and wanted to copy, open see here, can you see iterators? Okay, I can go to Python 3 and I can import this iterators module. Can you see I imported that? Okay, and inside that I can call my iter. Can you see? Okay, so from the module, okay, from the module I created iterators, I imported that. And let's create a itx equal to iterator dot my iter. Okay, itx, so which is just a instance of that one. Okay, but since it is it iterable? Yes, it is iterable. So why? Because I can pass this to, okay, itx, okay, it's to iter built-in function. Do you see this one? Okay, because iter does nothing but calling yeah, calling iter. And in fact I don't have to actually create a new object here. I can return self itself, okay, because itself is a iterator, itself is a iterable as well as iterator. Do you understand? Okay, itself is iterable because upon calling this, it returns a iterator, and itself is a iterator because it suppose that the iterator protocol returns the next when you are calling when you call the next method. Okay, so it equal to iter of itx, and it returns the iterator and call it next of it. You are getting next values. Can you see? But what is happening? Something is wrong here. Something is wrong. Yeah, so and I can refer this it dot current index 0. Okay, okay, because I created a new object. Let's do one thing. Okay, let me save this thing. Previously I returned a new object. Do you understand? Yeah, instead of self returning self, let's go to this again, import iterators. Okay, and if I call itx equal to iterators dot my iter, okay, it equal to iter of itx, okay, it next of it, we might be doing something wrong here. What are we doing? Oh shit. See, this is a very silly mistake. I put the here return. Okay, so you know when you encounter return, here rest of the code doesn't execute, right? Yeah, very silly mistake. Yeah, yeah. So take this x and return that at the end. Okay, or take it as element e, return here. Okay, so silly that mistake was. Yeah, and import iterators and create an instance itx equal to iterators dot my iter, and I can take it equal to iter of itx it, and I can call next of it. It should return. It is working fine now. See, and now it tries, after it reaches the end, it tries the exception, stop iterator. Do you see this one? Okay, stop iteration. So this going through all of this effort, okay, this is just the whatever we define here. Sorry, whatever we define here, uh, which is just an example of both iterable and iterator. Okay, so instead of going through defining a class, okay, and all this effort, so we have a way to actually define create iterator in a faster way using functions. So the generator means if a way to define iterator using functions. So how do you do that? Okay, if I have this colors, okay, see this one, define my colors. Okay, so and let's put this thing. Okay, so just I'll explain you what iterator is first. Okay, so if any function that is having, you see this one, define foo, if any function is having, okay, and just let's do one thing, okay, here yield, if any function that has a yield keyword in a body, which is nothing but a generator, okay, so what happens, yield keyword passes the execution, okay, until next is called. I can do something here, do something, and I can return something else, okay, yield 5, and do something again, sometimes do something. Okay, so this is a generator. So it's just like a yield is something like a keyword to produce, okay, the what to return when next is called. Okay, okay, so when I actually used it, no, check this one. If I call foo, when you call a generator, it returns it doesn't execute a whole function, okay, instead it returns a generator. Can you see generator object? Okay, so nothing is executed when you call this generator, okay, function, because it is having a yield keyword, that generator, that function is not executed. When you call a function that has a yield keyword, instead of the body being executed, you will get the generator returned. Okay, so now what happens inside of that, okay, now you can call, okay, next of x, if you call, so it will execute till the yield and then execution is passed. Okay, so if I call next again, and you see this something is printed here, and then it will execute until next value. Okay, and it returns that 5. And if you do this thing again, it will execute till the next yield, and in the meantime it will print whatever is in the middle. Okay, which mean to say printing in, I mean to infer, it will execute all the statements that are in between the previous yield and current yield. Okay, and then whenever it encounters that yield and it returns that value, and it stops the execution when all yields are finished, and you will get stop iteration exception. Okay, so this is just a way to define an iterator, in a compact way. For I in colors, yield of I. Okay, yeah, so that is about iterators and generators.